Hi guys, so this is 5G inverse functions. This is something that we were going to do during term one, except because we started school holidays a little bit earlier, we didn't have a chance to. So this is something that I'm going to have to get you guys to do as holiday homework. Alright, so an inverse function, like you can read what it says here, but it's just when you need to swap the x and the y values for that function, and then it will give you its inverse. So if you have just one specific point, so let's just say this coordinate here, when x is -1 and y is 2, if you wanted to find the inverse of that, you're just swapping those x and y values. So this point would turn into where x is 2 and y is -1. So that's the same with any point on the line of that original function. The coordinates are going to flip over, which we'll see pretty soon. And also, we're going to be dealing with the graphs of some functions, or the graphs of their inverse. From the original function, the inverse is going to be reflected in the line y equals x. So that's this little dotted line here. So anything that appears on this side of the line will be over here for the inverse, and anything that appears on this side of the line for the original function will be over here for the inverse as well. And there's a couple of examples that use that. Okay, so another one of the important things that we have to do is find the rule of these inverse functions. And it's a two-step process. So you just need to swap your x and y, as we are always going to be doing, and then you need to make y the subject. So let's just say we've been given this rule here. This has our function notation. Let's just change it to y for the moment, just to make it a little bit easier for us. All we need to do is swap that x and y. So this is going to become x, and that's going to become y, and then you need to make y the subject. So I'm not going to finish that one off. We'll do that a little bit later. Another important thing is this bit here. I've put it in bold because, as I said, it is important. So a function will only have an inverse if your original function, f of x, is 1 to 1. So if we look at this one, we can see that it's not actually 1 to 1. It's many to 1. So if you do your horizontal and then your vertical line. So if I wanted to find the inverse graph of this one, you're reflecting it in that line y equals x, but it would look something like this. Now you might be like, yeah, well, what's the problem with that? Why is that not the inverse? The problem is this inverse that we've kind of sketched here, this is not actually a function. So if we do our vertical line test, we can see that it has 2 y values for this 1 x value. So that's no good, that's not a function. So that doesn't actually work. Okay, so they must be, as it says here, they must be 1 to 1. But let's look at this next bit here. We can make the function 1 to 1 by restricting the domain, as it says here. In terms of restricting the domain, what I mean is just by making it smaller. So if I kind of do that same graph as we had above, this parabola, that's not 1 to 1, is it? And as we saw up here, the inverse function doesn't actually work. So if we just try to draw the inverse of this one as well, it's going to be the same. It's not going to work. However, if we restrict the domain, it might actually work. So the domain of this one currently would be R, or from -infinity to infinity. I might do another axis here. What I'm going to try to do now is try to make this 1 to 1. So if I keep drawing this one down here, as soon as I cross this bit, that's sort of our problem. So if I didn't have this extra part here, so I'm just going to cover it right now. If I didn't have this extra part here, can you see how it's now 1 to 1. Or perhaps if I covered the other side, it's now 1 to 1. So if I decided to do that part, I'd be restricting the domain to, so that would be going all the way that way because the arrow is saying that it's keeping on going. So we're going from negative infinity, and we're actually stopping at 0 here. And that 0 can actually be included. But if it goes anywhere past that 0, it's not going to be 1 to 1. It's going to be many to 1. But that's not the only one. That's not the only restriction that we can make to make it 1 to 1 here. We can do the other side as well. So you could decide to do that bit too. And the domain for this bit would be starting at 0 and includes the 0, and it's going all the way like up and across, but we don't need to worry about up for now because that's the range. We're worried about the domain, so it's continuing going that way. So it's going to go all the way to infinity. Now, another thing that we need to know that's going to make our life way easier is that because your x and y values are swapped, your domain and range have also swapped as well. So your domain of your original function here, it's actually the same as the range of your inverse, and the range of your original function is the same as the domain of the inverse. So let's just say they gave us the rule for f of x, and they told us what the domain is within that kind of mapping notation, function notation rule, and then they asked for the range of the inverse. You don't need to do any working out. You've already been told what the answer is. I'll kind of touch on that a little bit later as well. So let's have a go at a couple of examples. Okay, so the first one here, it wants to find the rule for the inverse for this, but also sketch a couple of graphs on the same axis. So it wants us to sketch this and its inverse on the same axis. But let's just do the first bit first, obviously. So let's find the rule. Now this was the part that we needed two things for, there was two steps. So we needed to swap x and y and then make y the subject. So let's just forget about this f of x for the moment to make it easier for us and just use y. Alright, so the first thing we do is swap that x and that y. So that's going to become x. That's going to become y. And now we want to make y the subject. So we're just going to kind of manipulate this and move everything away from y. Okay, so there's the rule. I've sort of done it the other way around to what I normally write, but that's okay. The problem here is though that we there's nothing telling us that this is actually the rule for the inverse. We need to use the correct notation. So this thing up here, f of x, that's just our original function. We need to show that it's the inverse, and this is how we know it would be the inverse. So instead of y equals, or f of x equals, we'd have to have the inverse equals, and then the rule that we found. Cool, so we've got our rule. That's the first bit done, but we need to obviously sketch as well. So I'll do an axis over here. I'm going to try to do this as to scale as possible, just so you can see the reflection in the line y equals x a bit easier. Don't necessarily need to put this line in, but I think it's a little bit better just for now to show where we're actually reflecting the graph. Alright, now let's just worry about sketching that original function first. So let's just try to sketch this. So this is telling us that our y-intercept is at -1, and we've got a gradient of 1/2. So I'll put that y-intercept in first. Let's just say it's here. And I'll label it as well. And if our gradient's 1/2, we should have an x-intercept of 2. So you can put like y equals 0 into that rule if you want to, or if you can do it in your head, go ahead. But it should be at 2. So if we want to go to scale, that's probably going to be around about here. So x is 2 and y is 0. Alright, so this is a straight line, so it should go something like that. And it keeps on going that way, and it keeps on going that way as well. Alright, so we've sketched our original equation. Because we're drawing them both on the same axis, it's probably better if I specify which one's which so we don't get confused. So I'll show that this one is f of x. Sweet. I also need to do the inverse. I'll use blue for that one so we can see the difference. But like, there's a rule for inverse. You could just sketch that because you know how to sketch a straight line anyway. So you've got a y-intercept of 2. So up here, and you've got a gradient of 2 as well. So it's going to be going up like that. But I don't know why you'd bother trying to find any points that you need, because every point that you need is already on this line. Remember, from our original, if you swap your x and your y, that's a point on the line of the inverse, or the curve of the inverse. So this here, this x-intercept, that's going to change to 0 and 2 instead for the other one. So that becomes a y-intercept of the other, of the inverse. So the y-intercept's going to be at 2 then, so around about up here. And this y-intercept is going to become the x for the other one. So the y-intercept's -1, which means the x-intercept for the other one is going to be -1. Okay, there we go. So we can see that we can connect those, and that's going to be the line. Now, as I draw my line through these points, there's something else that we need to kind of pay attention to or focus on, which is this bit here. Now, wherever the original and the inverse intersect is going to be along that line y equals x. Okay, so if your original line touches the line y equals x, that's where the inverse is going to intersect with it as well. Okay, so they are going to hit together just there. Now we can actually work out where they intersect, and we should, because if we're sketching any graphs and they do hit together, we should show where that is. It hasn't specifically asked for it as part of this question, but I'm going to do it anyway. Okay, so remember, when we try to find out where two lines intersect, you can pretty much just make them equal each other. You use simultaneous equations. So we've got our original rule, and then the rule for our inverse. So we're just solving for x to see what the x value for this intersection is. So I'll just try to do that. Sorry. I'll try to. Sorry about that. Yeah, so I'm just going to try to find that x value. Okay, so there's the x value. So we can say that it's minus 2. We want to find the y now though. So we can just sub our x value into either of those rules. I don't like negatives. I don't like negatives. So I'm going to sub it into this one because they both go through that point. Okay, now we ended up working out that that was minus 2. But that was actually a waste of time because it's hitting the line y equals x. So on this line, all your x values are the same as your y values. So you already found out that x was minus 2. So y is definitely going to be minus 2 as well. And we're done that one. Alright, so let's have a go at this one here. Now this one isn't linear, this one is quadratic. It's going to be a parabola, except we can see that we've been given mapping or function notation here, and it's specified a domain. Okay, now I'm going to do this maybe without, I'm going to do it without using the rule, and then I'll do it using the rule as well, because if you can sketch the graph of your original function, you don't even need the rule for the inverse. You can just do it from the other graph. So hopefully we remember from chapter 3, I think it was, quadratics, how to sketch this kind of thing. So I'm going to do that right now. Okay, so this is saying we got a parabola, and its turning point is going to be on the x-axis because there's plus 0 over here, so it's like turning point form. So you've got the turning point at x is minus 1 and y is 0. So that would be around about here. And we have, like it's a positive one, the tail is going to point up like that. We better show this important point here as well. So that's just our y-intercept, so if x is 0, so it looks like that's going to be at 1. If you make x equals 0, that means 1 squared, which is 1. So that's at 0, 1. Okay, cool. Now, if we want the inverse, all we really need to do here is swap those intercepts. So the x-intercept becomes a y-intercept, the y-intercept becomes the x-intercept, and it is reflected in that line, y equals x. So I'm going to do it underneath. Okay, so the x-intercept of the x-intercept of the original one is going to be the y-intercept of the inverse. No, what am I doing? Oops. There we go. I'll just get rid of that. Okay, and we need the y-intercept of this one to become the x-intercept of this one, so that's going to be over here. 1 and 0, 0. Alright, now remember where sorry again. Remember we're reflecting in that line y equals x, which is that imaginary line going on over here. So instead of it looking like that, it's going to end up looking like that. There we go. Okay, so that's what it looks like without even using the rule. Now it should actually be a little bit more kind of curved like that. So it actually looks like it's the parabola on the side. If I switch it like that, it should look like sort of a parabola, which it does. Cool, so we pretty much have answered that question, but I'm going to show you how you can do it with the rule as well. So you could find the rule of the inverse of this and then sketch the rule rather than using this graph at all. So I'll really quickly work out what that rule is. So remember, we want to take that rule of the original one, the first step to finding the rule of the inverse would be to swap over x and y. Cool. Now we need to get y by itself. So to get rid of this squared, we need to do a square root. And remember, whenever you put in a square root, you need the positive and the negative answer. And I'll talk about that a little bit later as well. There we go. So that's going to give us y equals plus minus square root of x minus 1. Now, I'm just going to show it with correct notation. So we need to show that it actually is an inverse. Sorry. Cool. Alright, now we can see here that we've got a square root graph, and there's actually two of them. There's the positive version and the negative version. So the positive one would go like that, and the negative one would go like that like that. Alright, so that's what we're going to need, isn't it? That's that sort of shape. So if we look at these two like square root graphs here, the positive one and the negative one, the positive one is the one that has that shape. The negative one would have that shape. We don't want that negative one. So with our answer here, if we were going to be giving the rule, I'd rub that out. We don't actually need that negative version. It's just the positive version. Okay, and like from what we've done in terms of square root graphs, you guys should hopefully be reasonably good at sketching that kind of thing. It's just your normal square root graph that's been pushed down one unit, and that's what we can see here as well. Alright guys, have a go at the questions that are in from the learning matrix that are in the lesson plan as well. If you've got any questions, again, make sure you post them on the Microsoft Teams. Don't be embarrassed or anything about that, or anything like that about asking your questions, because most likely if you've got the question, other people do too, and it's going to be way easier answering it for everyone rather than just you. Okay, awesome. Thank you guys.